Hello and welcome to my series on vectors. So firstly, let's define what a vector is. When we talk about vectors and scalars, we have scalar quantities which have got only a magnitude and vector quantities which have got magnitude and direction. Can you think of a few examples? If you're using this for revision, pause now and try and think of a few examples for yourself. Good? Have you thought of some? Let's see. Let's look at some scalar quantities. We have things like time, mass, speed, area, charge, as in the charge on an object, or if you're using charge in a series circuit or something similar, volume, work, energy, and temperature. These are all quantities that have only got a magnitude. You don't say 2 seconds left or an area 5 meters squared north or things like that. We simply have magnitude. As for vector quantities, we have things like force. If I push an object with some force, it goes somewhere in a certain direction. I have velocity, which is very similar to speed, but the difference between speed and velocity is speed has a magnitude, think of the speedometer on your vehicle, and velocity has a magnitude and a direction. We have displacement, which is similar to distance, but while distance only has a magnitude, displacement has a direction. Position, acceleration, weight. Weight is similar to mass. However, weight is a special kind of force, so it has a direction. Momentum and impulse. Now we will discuss direction. There's different ways to describe direction in vectors. If you only have something on a flat plane, you can say it is either going to the right or going to the left. Traditionally, we say that right is positive. However, this is just a guideline and not a rule. We call it a sign convention. In this case, we have a vector which is 4 meters to the right, and we have another vector which is 3 meters to the left. Note that we need to convert our sign to a direction. In this case, the positive has become a right and the negative has become left. We no longer say negative 3 meters, we say 3 meters left. Similarly, if you only have vertical components, we can also just have this simple up and down sign convention. In general, up can be positive. But again, this is just a convention. In this case, we have 3 meters up and 4 meters down. And again, we have to convert our sign. Our negative becomes down, and our positive, which we have not shown, has become up. That is for our simple one-dimensional distances and vectors. We also have using our cardinal points. Simple like a compass. We have north, south, west, and east. And we also have northeast, southeast, southwest, and northwest. In this example, we have a force of 2 newtons northeast. You just need to be careful with this one. Northeast does not just mean in this general direction. It is specifically 45 degrees east of north. Similarly, we have 3 newtons northwest. Again, it is exactly 45 degrees west from the north point, becomes our northwesterly direction. Next, we have bearing. Bearing is related to this, but we only worry about the north point. We measure bearing in a clockwise direction from north. If you have an analog clock, you'll see we go clockwise. In this example, the orange vector is 4 newtons at a bearing of 120 degrees. And you measure that bearing with your protractor. From the north, we measure 120 degrees and we have our bearing. We also have another vector, another force vector of 4 newtons at a bearing of 240. Now notice, most protractors will not measure above 180, so you will need to measure this angle here and add it to 180. In this case, the angle will have been 60 degrees plus 180 gives us 240. This is a bearing. We also have a few other ways of measuring direction. What you may also see are descriptions like the following: 20 degrees east of south. What that means is you start at south, so we're going to use our protractor, put the point of the protractor on the crosshair of your compass point, and we're going to measure from south. From south, we're going to measure 20 degrees towards the east. Good? And then we're going to draw our vector. For now, these vectors are not scale vectors, they are simply showing direction, and we will write the magnitude on. For example, this might be 5 newtons. We will do scale vectors in the next video. Please note that this angle is 20 degrees east of south, but it can also be described as 20 degrees south this way. So you start by starting at the south and move 20 degrees east. Notice here is the 20 degrees. Or you say 20 degrees east of the south. These are both the same way of writing it. Do you want to try and practice this direction? If you are doing revision, I recommend practicing now. Good? So this says 30 degrees north of south or west 30 degrees north. They both mean the same thing. In this case, we are going to again take our trusty protractor. We are going to start at west, because you see it says north of west. So we start at west and we're going to measure 30 degrees. Again, at the moment we are not doing scale vectors, we are just approximating the direction. We have 30 degrees, perhaps this is another 5 newtons. So now we have 30 degrees north of west or west 30 degrees north. It is the same direction. Good. Another description you may see, especially when dealing with forces, is the idea of 60 degrees from horizontal. In this case, or might say from vertical. But this one is 60 degrees from horizontal. Again, we need to have what is this time a Cartesian plane. It's not showing north and west. It is showing y to be vertical and x to be horizontal. You could also write vertical and horizontal, but this is the convention. Again, if you are needing this convention, often up is positive, down is negative, right is positive, and down is negative. Left is negative. This will be important later, but for now it is not. This is 60 degrees from horizontal. In this example, we are assuming it means up. For example, you are pulling a box, and you are pulling it at an angle of 60 degrees from the horizontal. This is how it would show on the Cartesian plane. You would take your protractor, put it on the crosshairs, measure the 60 degrees and draw your vector. Again, we are not yet doing vectors to scale, we are just doing direction. Perhaps this would be 10 newtons, and that would be 60 degrees. Those are the majority of the directions that we would use doing vectors in grade 10. I hope you found this useful. If you have any questions, you can leave something in the comments, or if you know me personally, you can send me a message. Thank you very much, and I hope you found this video on basic vectors and how to understand vector directions helpful. Good night.